Good evening, welcome to another YouTube video tutorial by Idani Prof Maoda. So tonight I'm going to do an example of variation of parameters. So we need to find y1 and y2. For us to find y1 and y2, we solve the homogeneous part. I think I had already shown you this example. So we let this to be equal to 0. Sorry for that, this is x, not e. So after that, we let y to be equal to a to the power mx. The derivative of that is m e to the power mx, and the second derivative is m squared e to the power mx. So from there, what we're going to do is to substitute it back into this equation. M squared e to the power mx minus 2 with the rest, you can just put m e to the power mx with the rest y, put e to the power mx equal to 0. From there you take out the common factor, which is e to the power mx, so you'll have m squared minus 2m plus 1 equal to 0. So this means that e to the power mx will not be equal to 0. M squared minus 2m plus 1 is equal to 0. So m minus 1 equal to 0. So this is an example of case 2 that I was telling you about. So y equals to c1 e to the power x plus c2 x e to the power x. So from there we will have y equals to we need to identify y1 and y2. So this one you can just call it y1 the power x and call the other one y2, or either way you will arrive to the same conclusion. If you look at this formula, we've got w1 and y1, y2. So we need to find Wronski's of y1 and y2. So to find the Wronski's of y1 and y2, do e to the power x. Just the first row is just the original function, and the second row is the derivative of exponential function, and the derivative of that ax plus x e to the power x. Because we use product rule, we keep it to the power x a constant. Derivative of x is 1 plus x constant. Now the derivative of exponential function is just exponential function. So we need to find the determinant of that. So this is going to be e to the power x times e to the power x plus x e to the power x minus x e to the power x times e to the power x. So this is e to the power 2x plus x e to the power 2x again minus x e to the power 2x. So these guys will cancel each other, so we'll have e to the power 2x. So that is our Wronski. So from there we have everything that we need. So now someone can ask me, what is this g of x? To find g of x is simply this function. So that's your g of x. So v1 equals to, and another tip, v1 goes with y2 and v2 goes with y1. Do not confuse the two. So this is negative. Where there's g, you can put negative e to the power x divided by x. Where there is Wronski, you can put e to the power 2x, and then where there is y2, put x e to the power x dx. So this is just v1. After some simplification, this is negative e to the power 2x divided by e to the power 2x of v1 equals to negative the x of v1 is simply negative x. So now let's find v2 in the same manner. v2 is given by g of x, which is e to the power x divided by x. Now y1 is e to the power x divided by e to the power 2x dx. So this is going to be e to the power 2x divided by x times 1 over e to the power 2x dx. v2 is 1 over x dx. Just quickly go to the next page. So this is 1 over x dx. So this is going to be v2 is equals to ln x. So now we said that the general solution is in the form y c1 y1 plus c2 y2 plus v1 y1 plus v2 y2, y equals to, with the c1 y1 c1 y1 put for x, y2 is x e to the power x, v1 is just v1, the one I found, negative x, y1 is that it's x, and then v2 ln x, y2 it's x e to the power x. Sorry for that, I realized that you couldn't see. Thank you very much for watching my YouTube video. Please don't forget to subscribe, like, share, or comment if you've got any questions below. Thank you very much. Love you all.